Great. All right. Hello, everyone. Welcome to today's webinar, a conversation with a cloud native developer. Today, we're going to take a look into the development, migration, and deployment of applications on Kubernetes. My name is Alex. I'm going to be the MC during this session. So just before we begin, I see people are coming in periodically. Just want to go over some housekeeping rules first. During this webinar, everyone's microphones are going to be muted. However, it's open discussion. So if you have any questions, if you just throw them in the chat at the bottom of your screens, we're going to dedicate some time at the end to answer all of your questions. And then lastly, this webinar is being recorded. So we're going to send this to everyone via email afterwards. Now, I would like to take some time to introduce our speakers for today's webinars. The speakers for today's session, they both have course and firsthand experience. So they're going to dive into the how and why during this webinar. I'd like to introduce Alan first. He is the lead curriculum developer for Mirantis training, and his tech journey has taken him from sysadmin, DevOps engineer to platform engineer. And he has nearly a decade of experience in learning and development, creating technical learning solutions for enterprises. And with Alan today, we have Zach as well. Zach joined Mirantis Zach joined Mirantis's solution architecture team as a New Jersey native. And coming from the consulting space, he's consulted and advised commercial organizations in the software engineering space and domain, helping them with strategic decisions, sharpening their software engineering teams, develop and modernizing applications, and educate on the latest architecture. So I'm very excited to pass the torch over to our two speakers today.
Thanks, Alex. Yeah, we're excited to have the conversation and get to share a little bit of the knowledge and skills of the practice here. So to kind of set the context of this conversation, again, this is going to be hopefully not death by PowerPoint. We're going to stick to a very conversational format here, and we're going to be putting Zach in the hot seat. So I get to ask all the questions. That's the fun part for me, and Zach has to do his best to answer them. But to kind of maybe give us so a little bit deeper insight into your background, Zach, let me ask you this. We've got a nice little resume here for you, but can you tell us a bit about your background and what initially sparked your interest in the field of cloud native development?
Yeah, absolutely. Thank you, Alan. Yeah, before I get to that, just a little bit on what I do with Mirantis. So I'm a solutions architect at Mirantis. I'm working a lot in the field, so a lot with customers, and we help them design and build and envision Kubernetes solutions. So I work with a lot of many different customers in different verticals. So I get to see a lot of different verticals, a lot of situations and use cases for Kubernetes. And what got me there or prior to that, I did a lot of cloud native development, which we're here to speak about today. And color in the line, so to speak, for our audience here as to not necessarily all of the what to do and how to do it, but more the whys and hows and everything around the what we're doing, why we're doing it, and that sort of thing. So my background, Alan, was first started in database development, in relational and non-relational databases. I remember in my intern years, who's the person that was always needed? And I remember it was the database administrator. They were always making schema changes and things like that. So I was like, oh, great, let me go do this. So that was in the early, that was in like the late 2000s. And back then, cloud native, I don't think that was even a word back then. And a lot of applications had one database and then many applications. And I think we can all know the problems with that. So later on in the years, I got to see like where, sort of the magic, so to speak, in the tech stack sort of shifted from the database more to the application layer and to the API layer. And that's where I kind of got drawn into application development. And then I went to, I love the customer facing aspect. Development, it can be very isolating sometimes. So I wanted to be in something that's customer facing. So I joined a consulting firm where we got to do a large variety of software engineering related projects. So that would mean in cases where you bring in custom software where off-the-shelf software doesn't cut it. It's something that needs to be customized. It's sort of like off-the-shelf software, sort of like it's like the Olive Garden. You can only customize it so much, but when you need to build the food from scratch, that's where custom software development, and that covers a wide variety of use cases and some of the most interesting use cases. So I could speak a little more about cloud native development as we get on the interview, but that's roughly how I got started.
Yeah, that's really interesting, Zach. I especially appreciate it. To me, it sounds like you came from looking at things from a very data-centric point of view, right?
Yes.
The data forward, and I think that's important often when we're talking about smart design. So
Yep.
looking forward to hearing your insights. So let's take a look at what we're going to be talking about. We've put together this loose agenda, again, conversational, but we've got a few talking points, and the slides here are meant to keep us on topic as best we can. So we're going to go over what is cloud native. We're going to talk a little bit about cloud native architecture, especially from the developer's point of view. Sometimes, we get so used to looking at it from the top down, we forget to look at it from the bottom up. So we'll look at it maybe from the developer's point of view. We'll talk, of course, about container orchestration. You almost can't talk about cloud native without talking containers and container orchestration. And then finally, some key considerations and any questions that come up. We'll save some time at the end for that. So This is the flow and the topics that we're going to be hitting at a high level, but let's jump into it. And we'll start off with this interesting diagram of cloud native. But before we kind of maybe dive into some of this, I want to get a couple of terms clarified, Zach. Maybe you can help us with this. When we talk about cloud native, there's sort of the overarching definition of all these things that encompass cloud native, but maybe we can look at it towards the end goal. So what would you say is the end goal or the vision of cloud native architecture?
Yes, so that's a very good way to put it. Is a lot of these terms loosely associated with could be lumped in with cloud native, but what is actually cloud native? That's a very good point, Alan. And one thing I wanted to note before is architectures have shifted from as I said, like one database and many applications to many databases and many applications now. So that's where the architecture has changed. It's just setting a context for that. So, but that's not like when we hear the term cloud native, what this means, I first heard it, I think maybe 2017, 2018. And what it really means at the core originally, and the definition has since evolved, and I'll get into that in a second, but what it really means is for applications to take advantage of the economy of scale features of the public cloud. So some of those features could be you have security out of the box, so like network security and things like that. Scalability, applications, you can scale them up and scale them down, and they're sort of elastic and meet the demands. You get optimized services like databases and messaging queues, and then you get configuration. I'd say optimized configuration, everything with the click of a button. So that's what the applications prior to this term were not optimized for that type of environment. And what cloud native originally meant and still does is to optimize to take advantage of those types of features. Where it has since evolved, and we're going to talk a little bit about this later, is when you build your application in the cloud. One of the things that you'll notice right away is you can potentially and very easily lock yourself into a type of architecture or platform or something like that. So when I hear cloud native now, back in the past, it was very cloud centric. Now I hear it to mean more, yes, we like those features of the cloud, but we want it without the lock-in of the cloud. Mm-hmm. And we'll talk into the why and how of those pieces later. Yep.
Yeah. No, I think that's a good point, right? Sometimes the tools can be a bit too unitask and a bit too specific, and we want to be able to have that flexibility still. Good. Yep. So, I think that, that was a good answer as far as like what the end goal is. So what would you say that would mean for individual developers, right? From a boots on the ground perspective, how do we look at cloud native?
Yeah, so it means a lot. Yeah, that's a very good way to put it. It does mean something different for developers and architects on the ground who are building cloud native architectures. And we'll talk a little bit about later about the challenge, some of the the drawbacks, and then also some of the missed, or I guess it'd say underestimated or unseen advantages of cloud native architecture. But I remember when I was building my first cloud native I guess you'd say applications. It was an application modernization project at a large pharma and crop sciences company. So we were coming in and we were containerizing and modernizing applications. They were running on VMs. So we basically Dockerized them, we containerized them, and then we put them on Kubernetes, which we'll be talking about a little later. And we refactor the applications to make them cloud native and fit into being run on cloud. But what that means for for a developer's point of view, as I was doing that, is your application in some ways, going cloud native makes the hard things easy and the easy things hard in some aspects. But where the rubber meets the road, or what this will really mean, is you should count on or assume that your applications can scale easily, and also simultaneously that they will fail. So when you're building applications on these distributed architectures and you go into that means there's a lot more pieces, or one little part breaks and it causes a lot of other pieces to break. So you should assume that, like, that's the mindset shift I had to make when building in cloud native architectures as a developer. Is yes, the scalability, and in the past that was a little harder, but doing a lot of QA testing, and then also making sure that the application is resilient from not necessarily like a hardware breaking, but from software breaking. That's what's changed a little bit.
Yeah, no, I think that's a great insight, right? Sometimes we have to keep in mind that the trade-off for that scalability often is stability, right? And we have to plan for that.
Yep,
So
exactly. And it's a worthwhile trade, in my opinion. I think it's worth it to be able to do that. You just have to work a lot more on building a lot of. So, for example, you would need to be very careful about how you log your application, and building tracing metrics to see, like, when you have these big distributed architectures, you need to be able to see what's going on. It's a lot harder to do that in a distributed environment. So, but we'll be unpacking that a little later. Yep.
nice. Yeah, looking forward to that. So, it was interesting. You mentioned being a part of an organization that did this modernization task of sort of shifting from a previous way of doing things to this new cloud native way, Dockerizing, containerizing an application. So maybe you have a perspective on why do you think that companies are moving to cloud and cloud native architectures? What's the draw for them?
So yeah, this is a very, very interesting question. And it usually happens the way, tech works. A lot of time you see someone doing something really successful and say, oh, what are they doing? And they sort of run with it, whether they have an efficient team, or another organization is able to do things faster, better, cheaper. But I would say there's two simultaneous things going on. The first is that and this has always been, and it'll continue to trend, is the standards for applications have gone up. So what this means is more uptime. You expect more uptime from applications. You expect more quality. You expect more functionality. The big tech giants have pioneered this: Facebook, Google, and Amazon, who've built all these cloud native tools. So one of the questions is if tech companies are able to do this, why aren't banks and other non-tech companies able to do this? So how do you achieve this without needing multiple specialized Google teams? And you already need a lot of teams for software development, and you don't want even more of that. So that's the first factor, is you have that sort of pressure, so to speak. The other factor is being cloud native takes companies closer to the vision of solely using tech is just there to build business value, and software is one of the best ways to do that. And if businesses and organizations are able to focusing on that, and software being we're in the information age, and software and applications are the steam engine of that. So with the cloud, you're able to get all these features and solely able to focus in on building the software, building the business value of that. So those are the two factors I see why organizations are making a very, I don't want to use the term Herculean because it's not impossible, but a very hard, moving past very big barriers to get there.
Yeah. So, you mentioned some of those business values. Is the adaptation to cloud native really going to be worth it for companies? Does it make them more efficient? Have you seen that, or what has been your experience with
I would
companies make the
say
transition?
yes. I would say overall, yes. So one of the overlooked factors of cloud native applications is not necessarily the technical benefits, but the how would I describe this? Like the organizational skill set slash alignment with the market. So what that means is if now that we have a large variety of tools, simultaneously we're also unifying on, and we'll get into a little bit of this later. There's a paradox of like we have all of these cloud native tools out there to we're also unifying on ways of building software. So when you go cloud native architectures and all the things that we list here and all of the, and we could talk a little bit about each one of these. When you like work in or under and have experience with these factors, you're able to take a developer and transfer from team to team very easily, and then you're also able to align your organization with the skill set of what's being learned in the market. So that's why I think is the number one benefit. It's even outside of the technical benefits. Also, we mentioned before cloud native being able to take advantage of the public cloud and having the not needing to rebuild the wheel, so to speak.
Mm-hmm.
Those are the two major advantages that I see with cloud native architectures. And but before I touch on that, I'd also like to note something on the slide here. One of the major other benefits is everything is going into code, and we'll talk a little bit about this, is being able to build and stand up your infrastructure in terms of code, being able to spin it up and stand it down and define it in very exact terms is another benefit. So that so to speak, infrastructure as code gives a rise to this saying that this new saying that you want your servers and infrastructure to be cattle and not pets, meaning that they're very indistinguishable, and you don't have a pet server that because that one when you treat your infrastructure as pets, they're very personalized and them, but the downside to that is when they go down, then you have very specialized servers and infrastructure for certain things rather than being able to do things at the click of a button. And I see organizations want to take advantage of that.
Yeah. I've heard a similar analogy of farmers versus gardeners, right? Like each plant needs tender care versus the mass, where everybody kind of gets the same thing, and
yes,
you're not as concerned about an individual plant.
Yeah,
that's no.
Yeah, and I want to note, Alan, like in some contexts that can sound kind of scary, like when we think of like when we think of like I'm trying to think, like we all like personal care, that's who we are as humans, but in the context of building software, it doesn't make sense. So in that sense, it's a very good thing.
Nobody likes a needy application, right?
Yeah, exactly.
So let's talk a little bit more then to kind of shift this maybe from the other side of things, because cloud native obviously isn't a silver bullet, right? It's not going to be the end all fix all. There's going to be something that's going to come next. But what do you see from organizations or developers who are starting off in cloud native? Where are the misunderstandings? Are there things that are often being maybe undersold, oversold, or just misunderstood in general?
Yes, absolutely. Yeah, it's like going with any new architecture or new way of thinking about things, philosophy. There's always downsides, and with cloud native architectures, one of the things like having transformed an application from I guess you'd call it a modern or not a modern, an older 3-tier architecture to something like microservices is the hardest thing, the biggest technical challenge that I think surprised everybody was testing becomes a lot harder. So when you have like a monolithic application, maybe a non-modular one, you would have everything you would need would be there. You'd have the application, you have the database, you only need one thing. But now with a distributed, just these distributed architectures, you need you need many dependent services, and you need lots of you need the database state to be right. So there's challenges now in building development environments and having them match production. That problem became even more challenging. And as a developer, like you need more than just everything on your machine. You're going to need a bunch of services out there, and they're going to need to have the right data. The part that's undersold or less, I guess I say less realized or less appreciated from cloud native architectures, and is when you move to a cloud native architecture, it's designed to support something called vertical teams. So what that means is, as opposed to having, your infrastructure team and your development team, now they're separated by business units. And what that means is they can operate independently. They can use different types of languages, different types of frameworks, and they're able to operate independently and upgrade their services as needed. So that model is much stronger for aligning technology to business than the traditional organization where you have IT and then you have the business, where these vertical teams sort of bring and make those a little more of a hybrid. And that's why you see agile and a lot of other things come into play there that fit nicely.
Yeah, I've definitely seen that shift myself, and can agree. I think working in those vertical teams feels much faster and like fewer barriers, right, to getting the product out the door.
Correct.
Which has always been nice.
Yep, exactly. Yep.
Well, let's talk a little bit now about this sort of progression, if we will, here. This is the right one. So this is our cloud native maturity model at a high level, right? And of course, these things are always up for debate. You'll get people with different opinions on what should go where, but this gives a nice, simple overview of maybe where organizations might be at in their phase of cloud native maturity, going from an initial exploration phase all the way to a mature, optimized phase. But when we're talking about the individual developer, right? Maybe they're in a company that's in this initial phase, or maybe they're looking to just get into the cloud native space. Can you give us an example of how you would approach a project in a traditional development stack, and then how you would approach that same project with a cloud native architecture?
Yes, exactly. So a traditional stack would be more, as you mentioned before, more, I don't want to say horizontal teams. So what we would approach is we would do this long, I guess you'd say, how do I want to say this? You'd have this long, and I want to say almost waterfall-like approach, waterfall being almost the opposite of agile, where you gather the requirements and then you build the application, then you test it, and there's a bunch of phases in there where you go from one step to another. So with the older architectures are conducive to that type of development, although you can use agile in older architectures as well. So, but how I would approach it first from that point of view. I would, and with those type of architectures, you sort of need everything all at once. You need to build, you need to have the requirements up front. You need to have the making corrections later is more expensive. Whereas with more of a cloud native model is we would build maybe like a minimum viable product or something very small, or a very small service, something that just does something very basic. And then we would slowly build services around that. So there isn't like this big upfront design phase, although I think those are always helpful. I'd say you do things a little more in the agile iterative way. That's how I would, like, from a project point of view, approach like a more cloud native mature organization would most likely approach it that way. And that's how I would approach it. So, but we have here on the maturity model here to where it's more of the traditional architectures versus what we have today in cloud native. So, so for example, like when we talk about fully integrated to cutting DevOps practices, what that would mean is, for example, like in a cloud native organization, is what they would have is they would implement something called GitOps principles, which basically means whatever you have in Git happens in production. So whenever you make a commit to your code, there's some tool or some process that automatically picks it up, and you can be pretty confident that it's going to deploy to production, and there's going to be no configuration drift between the two. So that's how that's an example of what I would. Whereas before, you would what you would do is you wouldn't have any of those tools. You would manually build the code. You would push it out to testing, see, okay, great, that works, and then you manually push it out to production. And who knows what happens to your code base behind you, So rather than having these automated processes which help save time with a lot of the standard approaches that you would need. But you also have to make sure that automation doesn't bite you in the rear end, so to speak. You don't push a change that you don't intend to, and that sort of thing. And that's why you need a lot of gatekeepers in between, so to speak.
Yeah, and a good test and QA environment helps. So yeah, and I appreciate what you're talking about, with, you were talking about waterfall versus agile. And that's one of the, I think, things that I've seen cloud native really unlock is that idea of how do you eat an elephant? And if you've heard that one before, right? How do you eat an elephant one bite at a time? And previously with, traditional development, you did have to kind of build the elephant all at once. But with agile, you can break it into its smaller pieces, right? And it's a bit more manageable, and it feels more achievable or faster to build, at least.
Yes, exactly. Yeah. And another thing you can do is, I know pretty early on, like, like let's say I was building a service and it starts to get a little too big, so to speak. I would start splitting that apart earlier on rather than just bolting on too much onto an application and things get intertwined and dependent. Whereas with the cloud native, you'd start what you said, like building small. And if things do get too big, just know early. It's easier to break them apart earlier than later, So
no, that's an important, I think, piece of advice there, right? Don't be afraid to take a step back and realize that you're starting to build a monolith when you meant to build a microservice, right?
That's exactly, yeah. And that's another thing I'd like to mention before when we talk about drawbacks and challenges to cloud native is I notice in cloud native architectures, yes, you're getting all these benefits, but the challenge I mentioned was testing. And then also I find myself refactoring my own code more frequently and earlier in cloud native architecture. So I would put that in as like, hey, and that's one of the hard things with, Agile helps with that because it advertises the work to do something to the business and saying, hey, we have to clean this up. What are the consequences, So Agile does help. That's one thing that I've noticed, that Agile really does fit well with these new types of architectures because you're able to quantify and explain, refactors and changes that you need to make. Whereas before it's like, well, we need to change something and it's going to take us 3 months, and well, it's going to take us 3 months to explain it, so we're going to go get started on it, sort of thing. So it brings the businesses together, business and IT together, which they should be a lot more tightly integrated.
Yeah. Yep. So far in our conversation, Zach, I think we've covered a lot about approach, about process, and about organization, which I think is important. A lot of organizations, or at least I'll say this, a lot of developers kind of skip over that and they want to get right to the fun stuff, which is the tooling. But taking a moment just to think about, right, what are the processes that need to change? What's the organizational things that need to change to make cloud native a reality for your organization, I think is important. So I'm glad we kind of put that up front.
Yes.
But we have a slide here that helps us to transition into the tools, because you can't talk cloud native or microservices or as containers coming up. So how do containerization come into the picture now? Why is it so heavily linked to cloud native?
Yeah, that's a very good question. Now we're going into the how phase. So containers fit. When I was talking about before, one of the cloud native, I don't want to use the term originally, but originally was used in terms of getting your applications to work with cloud public cloud tools that give you the scalability, configuration, and everything like that. We mentioned one of the downsides was vendor lock into that, as like, hey, like I'm locking myself into like, for example, like Amazon ECS, that's a container orchestrator, so to speak. So when you lock yourself into like a specific service or proprietary API or interface, you're not able to move around. You almost bind yourself and your data to a specific platform. So if there's price increases or anything like that, or there's mergers and acquisitions, that makes things infinitely harder, because there's software is constantly coming together, then breaking apart, coming together and breaking apart. Especially you see that a lot with mature organizations is, well, we have a merger. Let's make a unified portal. Oh, this doesn't make sense. This needs to be broken off. So there's this constant coming together and breaking apart. And one of the things that containers, and I'm going to speak to the audiences if they've done a Docker 101. One of the things containers does is it makes your applications portable. So that container image that is something that's widely, I'm trying to think, it's the modular container, as we see here in the picture, is a very good example. Instead of your code becoming spaghetti, so to speak, you're building it with Legos. So with the container interface, you have this runtime interface, so to speak, that can be run anywhere. So in that container, you have the flexibility of having your own. You can pick the operating system that it emulates. You can pick the language. You can pick the frameworks. You can build all these things into it, while also having portability as well. And it also being another benefit is containers are more efficient than virtual machines. You're able to fit more compute, you get more bang for your buck in compute with containers. So that's where containers fit into microservice architectures is, and we'll talk about orchestrators in a moment, but containers really help out, or they help alleviate the lock-in.
Yeah.
Yep.
Yeah, no. And yeah, shipping containers, classic example of that, right? That kind of just standard format.
Yep.
Makes it easy to lift and shift. Yeah. So let's talk now about orchestrators for containers, because when we think about VMs, we often think, oh, okay, well, I've got my orchestrators. I go to the cloud and they've got their own orchestrator for virtual machines. That's what I call cloud servers, right? Or maybe I'm using OpenStack and Nova or Amazon and EC2. What is there for containers? What are the big ones? If we haven't heard about it, I'd be surprised, but let's just introduce them.
Yeah, absolutely. So the first one was Docker Swarm. That's a more closed source proprietary version of well, before I get into that, orchestrating containers is once you have your application, it's just a container. It needs to be able to talk with other services, other applications. That's what an orchestrator does, is it says, hey, it orchestrates all your containers to work together, and you can build them up into services. And it also defines the infrastructure. So that's what an orchestrator does. The first one was Docker Swarm. And then now the big one is Kubernetes. You have the Kubernetes API. So to my knowledge, Kubernetes is the first distributed orchestrator that we have out there. But what makes it so valuable is what orchestrators do is they also allow you to define scalability for your software. So if you need a particular service, it's getting a lot of traffic, you need to scale up, it can scale up, and then it can also scale down too as well. But the overlooked value of orchestrators, and I don't know, if I had to guess, I don't think that the original authors of Kubernetes were thinking about this, is what container orchestrators gave the ability to do was it gave a well-known API to build distributed software on. So where that changes things is before you would traditionally deliver software through virtual machines, and a virtual machine only knows about itself and its hypervisor that runs it. It doesn't know, it doesn't have features to be able to, out of the box, to be able to build distributed applications. And when you think of applications, almost all of them are distributed. I can't think of one that isn't, that I've worked with. So what the Kubernetes API does is it gives applications and whether you're building applications for a customer, it's the ability to have a consistent application experience across clouds, whether you're on-prem or you're in the cloud or anything like that. And that's valuable, A, for developers, because you don't have to learn a new platform, and then B, also for operators. So for example, you have MongoDB out there and they have their own database. They're able to build a Kubernetes API that you can just plug in and you have a fully production-ready MongoDB database ready to go and ready to use. So you, for the first time, you have an API with a distributed, you have an API for a distributed architecture, which is very valuable.
Yeah, no, I agree. I think, no container really runs in isolation. I would agree with you there. I've never seen one that didn't depend on other things running at the same time. So an orchestrator, yeah, is invaluable. And I think especially if we're talking to developers who are just starting their cloud native journey, they need to be aware of these orchestrators, right? Correct. Because when they start designing their application to take advantage of all these features you've already highlighted that these orchestrators can provide for them, they need to know which orchestrator they're designing their application for. Because while they have similar benefits, they do vary quite considerably in their implementation of these things. So maybe I can get your opinion on this. We're not going to say this is each has their pros and cons, and each person will have to make their own choice. But maybe we'll get Zach's opinion. If you were just starting as a cloud native developer, which one of these would you have in mind to try and learn first if you had to pick one? And then maybe why?
Yes. So I would start. I liked where you started there was before we get into the more the softer things is the like Kubernetes is a must. It's everywhere now. I think like 90+% of organizations are using Kubernetes. That's an absolute must know. Just because of its value as a standard platform to build applications and run applications, you're going to run into it. And there's just being more and more built on that every day. And I just assume that's just going to continue to grow. And hand in hand with that is Kubernetes does support Windows, but another thing that hard tool or skill or area, so to speak, that you're going to need to know as a cloud native developer is Linux. Yes, there's still Windows development out there. But I see a shift more towards Linux-based workloads, and with the customers that I work with, a lot of people love the Linux experience that it gives, the flexibility of open source. So I would say those are the two like hard skills to know, regardless of what framework or language that you choose. So hard skills, those two are good to navigate and know. The other thing to get started as a developer who's considering specializing in cloud native design is the way that I get started is without, I would, after you take a course and you get familiar with some of the tools, the first thing to do is just build your own mock application. So for example, I build a very small fictional, let's call it like e-ticket application where it's a fictional organization wants to build an e-ticket service. What would that look like? What would a part of that look like? And that's what I build to learn, to get familiar with some of these architectures. So I did that to learn. That's how I learned after I did some courses in education on Kubernetes. That's how I got down and I started, learning like a little bit more was by doing that as I built that application on Kubernetes. The other thing that I would also mention is that something that's overlooked is the quality of your documentation. This is a must. So a lot of people, the people that you're going to want to work with, the thing that you're going to be most impressed by is not necessarily like the application, but how well they document it. How well did they say why does the application exist? What does it do? How do you get started with it? What are some good tips to know? What are recommended ways of running the application? That sort of thing. In a very just short and concise way that the person who's likely to pick it up, like getting their information. So that's something that I see across the board that I think you're going to stand out a lot from that. And not only are you going to learn more, you're going to be able to, you're also going to stand out a lot more.
Yeah. No, I'm really glad you actually mentioned that on the documentation front, because I think that's a common weakness among developers, but especially when we start working more in these, like you said, vertical pillars, and you have microservices all trying to talk to each other. Having that skill of being able to write documentation so that team A knows how to talk to the service that team B built, and vice versa, is critical. So yeah, I'm glad you highlighted that.
Yeah, exactly. Yep. And that also goes into the other piece I would recommend is, because this is a very big and complex space, is rely on a lot of your friends and colleagues that you met for experience. So always ask them what they're doing and what they've done. Always catch up, because sometimes it like there's so many like being a developer is almost like being in the medical field in some ways. There's heart doctors, there's brain surgeons, and that sort of thing. You can't be a doctor in everything. The human body is much more complex than applications, but applications are still very complex. So always checking and seeing what your friends are doing and what they're doing and why they're doing before you go in and you invest a lot of time into learning something. There are some things that I mentioned before that you're absolutely going to need to know, like Kubernetes and Linux. Absolutely, you're going to need to absolutely go and do that. But for some of the other stuff, I would consult some of your friends and colleagues to see what they're doing.
Yeah, no, excellent. And I'm going to move us along here. We have another webinar scheduled that dives deeper into the tools. So we'll leave that as a teaser for that one coming up. And actually the same thing here, we're going to talk just briefly about microservices, because we've been talking about it throughout this webinar, because frankly, when most people think cloud native, they are often thinking microservice and not necessarily the broader term. So I think it's important for us to discuss just briefly microservices. But again, we're going to have a later webinar in this series about cloud native design, which will go into microservices a bit more. But let's talk a little bit about, from your experience here, how does everything we've talked about, cloud native, the tools that kind of developed around cloud native, the value that cloud native was offering, how does all of that come or impact microservice architectures?
Yeah, absolutely. That's a very good question, because microservices are lumped in with cloud native architectures very often. And they in their strict definition, when you look at the definition of both, they're very different things, but they often relate. And I'm going to get into that. So the way that I would define microservices is applications working in a distributed way over a networked interface. That's how I've seen, like, when people use the term microservices and what they build out there. That's how I would define it. How I've actually seen, there's probably a more textbook definition. But that could mean, like, why I say network interfaces, because those change all the time. It could be REST, it could be gRPC, it could be GraphQL. There's a bunch of interfaces that you can pick, but that's how I would define microservices. And where this fits into cloud native architecture is, I would say it goes into the vertical team more. It's more of an organizational change than it is a way of thinking about your applications than a technology change. And when we were talking about cloud native before and what that can enable with the cloud, with vertical teams, and them being able to choose their own architectures and everything, that's where I would say what aligns is, when you have the flexibility of being able to choose your own language, framework, and everything like that, and being able to, as opposed to a monolithic application where you can do things called modular monoliths, which is like it's similar to the microservices. As opposed to building a network interface, you build modules in the application. But I would say this fits in with the vertical teams piece that we mentioned before about cloud native being conducive to that. It's more of an organizational mindset approach than it is technology. I would actually say that microservices fit more in with have more to do with Kubernetes than and I would put it like this: microservices fit well into how Kubernetes makes distributed applications, and Kubernetes fits well into cloud native. That's probably a better way to say it. If you go from microservices to cloud native, it's less, there's less relation there. But if you put, when you bring in the Kubernetes into the picture and how it sets up applications and distributed applications and services, that's where the connection would be.
Yeah. And I think that's a good point. And again, often overlooked in these discussions is that the organizational changes to make microservices happen is often just as important as the tooling that actually enables it on the hardware, right? So an important thing, I think, a takeaway from what you just said. I appreciate that.
Yeah.
So let's kind of wrap it up here. I'm noticing our time is ticking away. This is kind of just our kind of closing out slide, if you will. Here, we really just want to kind of, if you could summarize, now that you're looking back on your journey of starting in cloud native, all your lessons learned, where it kind of shifted, how it's changed, what advice would you give to an aspiring DevOps engineer or cloud native developer who's considering specializing in cloud native designs?
Yeah, so that's a very good point. I would the first piece is I would remember that you're specializing. So I would pick a track to specialize in. Within the rough categories in my head, there's more than these. Is a developer would be one where you're building the code. Infrastructure operations, where you're also building infrastructure, but it's code now.
Yeah.
And then also DevOps, the people who do the code releasing and all the tools and processes to make development easier and better. So I would start by picking what problem you want to solve. I would start there before you get overwhelmed and you become a heart doctor and a brain doctor, and you don't pick too much. The other thing is to be cautious about initially when you see this is both in proprietary and open source projects, is what the front page and marketing says is going to be a little different than what the tool or project actually does. And I'm not meaning that it's going to do less than what marketing says. It could actually do more. So for example, like with Kubernetes, they advertise themselves as a container orchestrator. Yes, it is that, but what it enables and does is a lot more than that. So I would jump in and I would actually use some of the tools and services and to get the light bulbs. Oh, I get this, do that. And then also when you're going into cloud native, ask yourself, what am I, what tool you're picking, what database, what all the projects and frameworks that you're looking for. Ask yourself, what are you locking into first? The Kubernetes API is a very good API to build upon, and I think that's a very safe one just because of the health of the ecosystem and the amount of tools and processes and everything being built around it. So that would be an example of a very good foundation to build upon. But when it comes to the other kind of stuff, really look into like, hey, is this going to be around in 5 years? Is this, am I locking myself into a proprietary way of doing things? So I would ask yourself those.
Yeah.
Yep.
Yeah. Excellent. I think advice for any of us. So looking forward, right? Common tooling, design decisions, those are all things we also have to think about. So we'll just kind of position this here now. Then, we've got the continuation of our conversations. We'll have a webinar that will focus on design principles for a cloud native application. That's going to be October 31st at 1 p.m. So same time, basically. Cloud native tools of the trade will follow that one on November 7th, again at 1 p.m. Eastern time. So the links are there and you can get them from ExitCertified as well. But as promised, we tried our best to save some questions for the end. So I'm not sure if any had come in, or maybe if Alex, if you're on, if we were able to see any questions come in so far. If not, they can ask them now.
No, I haven't seen anything come into the chat yet. So We do have a thank you so much from Lewis. So thank you, Lewis. But if there are any questions, yeah, please feel free to put them in the chat now.
Yeah, awesome. Hopefully no questions means that we answered your questions as we were going through it. And
Yep.
that's can be a good thing. Yeah.
Yeah,
That
can
means
be.
we were on target here.
I
But
could,
go ahead.
I was going to say, if you had any closing statements, I could go over my slide too while we wait, perhaps if there are any come in.
That was going to be my suggestion. Yeah, I definitely appreciate everyone's time here. Did we get any questions yet, or do you want me to go to the next slide, Alex?
No, we actually do have a question coming through. This is great. So the question is, as a DevOps engineer, how can I create the right infrastructure for my cloud native developers to move applications between different clouds?
So let me maybe clarify a little bit. We're going to make some assumptions on this question here. That when we're talking about different clouds, we're talking about maybe different public clouds, maybe even private clouds. So maybe you're talking about an OpenStack environment and an AWS environment, or an AWS environment and an Azure environment. So I'm going to assume that he's talking about moving his workload from one of these public clouds, perhaps for redundancy or just to avoid lock-in. So how can you create the right infrastructure to give your developers that sort of flexibility? Zach, what would be your take on that?
Yeah, so this one is the first thing that comes to mind for me is like what foundation was built upon. If you're building upon the Kubernetes API, you're going to be able to migrate your applications easier. The challenge part of that is state. Um, that's going to be a problem ad infinitum going into the future. So what I would have done is I would first build your applications on Kubernetes. Then that's going to make transportation and portability easier. And then also ensure, like when it comes to state, what I was mentioning before is I was a database developer a while ago, and the ideal thing you'd want to do is you'd want to be able to, whatever data or state that you have, you want to be able to replicate over securely over the internet to whatever location you're going to, and then just point your application to the new database, so to speak. So there's a million ways to do that, but those are the two concerns I would have. Is I would be thinking what orchestrator or what platform am I building my applications upon? And then also the state, how do I get my state there? And then building your tools upon, and then making sure that being a good foundation, then building all your tools around that. That's how I would think of it. I'm sure there's many other ways to do that. Alan, do you think that?
Yeah. No, I think you're right. And I think the way to do that is just like you said, Zach, is look for an abstraction layer that you can provide on top of the cloud so that your developers are interfacing with a common layer that is independent of the cloud platform itself, right? So with that, for example, you give the example of Kubernetes. I think Kubernetes is ideal for this, right? If your developers just have to worry about, can I work with the Kubernetes API? Then it doesn't matter to them whether the Kubernetes API is running on AWS or Azure or OpenStack.
Yep.
They're speaking the same language, right? Now, the trap here is that many public clouds offer their own proprietary Kubernetes deployments, right? You can go EKS, you can go AKS, and they have their own sort of Kubernetes as a service. Those work great, right? And they're very quick to turn on, right? And to enable and just get running up with. However, they often differ in feature sets that are enabled, or in versions that they have deployed, or in their implementation of certain things, right? The networking or the storage, et cetera. So that's kind of just the one thing I would say to keep in mind why you can do that. And sometimes you can find parity between the two. Perhaps if you are really concerned about that multi-cloud deployment, look for a way to abstract that past the provider themselves so that you have a standard Kubernetes deployment, regardless of the cloud platform, and you're not relying on their standard deployment versus the other guy's standard deployment. Yeah. So, things like the Mirantis Kubernetes engine, for example, just to kind of poke that, is an excellent example of that. Deploys easily onto a cloud, but is abstracted above the actual provider layer. So giving you that flexibility.
Yep, exactly. Yeah. And providers really do. It is a danger to have your application locked into anything proprietary, because you can't move, you're stuck there. And who knows what's going to happen in the organization. You just want to be able to move around very freely, and that's the beauty of, and that's where open source fits in. So I totally agree, Alan. Yep. Open source interfaces. Yep. Unique software, but very open source frameworks. That's the ideal scenario. Those two work very together. As companies should be focusing on unique products and that fit the market while being able to be portable and flexible, while having working on commodity hardware with open source frameworks.
Yeah. So I think I saw a couple other questions come in through the chat.
Yep.
Yeah, there was one, if this wasn't touched upon, someone had asked, cloud native applications and the near real-time aspect, do they fit together?
Cloud native applications and the near real-time aspect.
Near real time. So what I would take near real time to mean is, like, let's say a user, I don't know, something happens in an application, like someone adds a record or something, and there's some dashboard somewhere that automatically updates. I would say that's more of a process. I'd say that's I'd say that's orthogonal to cloud native. It can or cannot fit with it. I haven't seen those two associated. Alan, do you have a?
Yeah, and again, I think maybe it's just understanding the question and where they're coming from. It. The way I kind of understood the question is, I think a common challenge when you have decoupled applications, right? And you're talking about perhaps processing something that is expected to be near real time, right? And yet you have this latency of one service talking to another, waiting for it to finish a process, coming back, or maybe talking to many services that are asynchronous. So you're getting one reply from service A, but still waiting for service B. And then by the time service B comes back, it's processed the data at a slightly later time. And there are applications that, that sort of a time drift can be very sensitive. And that's a hard one to solve. And I think that's a much longer solution to dive into, much harder one to dive into here, if that is what the question was. I will say this, I don't think that eliminates cloud native, right? You can still do that in a decoupled way, depending on how your data is stored, archived, and architected. Yeah. And I think that's really the key there, is how is the data there? Can both applications look at the data that is at the slice of time that is correct, right? Or is there going to be this delta between the two? But again, I think a little harder for us to answer here in the time we have.
I see what you're saying. In my experience, it's been the latency between services and considering the use case has not been an issue. There's been other issues we've dealt with. So very well said. The latency is usually very small, like network latency between services and how long it takes to get data from a database and bring it back. And it's usually not that bad.
I see one here about Terraform. Yeah, that's another great tool that we didn't get a touch on yet. But when we were talking about infrastructure as code, I think Terraform is still the de facto. That's the one I've seen most organizations still using. And honestly, I use the most as well. So yeah, Terraform works great in this sort of cloud native world. Well, I think that's about the time we have. I don't see any other questions unless I'm missing something. So we'll just say thank you. And Alex, I hand it over to you as well for the conclusion here.
Thanks, Alan. I appreciate that. Yeah, just at the top of the chat, I want to point out the webinars that Alan had mentioned previously. You can register for those upcoming ones. We're really excited about that. So those are at your disposal. Really briefly, I just want to touch upon some of our exclusive savings programs that we're running currently. So if you pre-purchase a certain amount on training for your team or perhaps your organization, you will earn prepaid training credits across the ExitCertified, WebH Solutions, and ExitCertified brands. So we're excited about that. If you happen to invest over $100,000, you will also gain access to 2 complimentary private webinars exclusively made for your organization from a variety of topics that you can see on this slide here. So I'm going to include the link to this page. If there's any further inquiries about that, you can also see that on our site. And I guess with that, we're at the top of the hour. I just would love to say a big thank you to Alan and Zach for presenting today. It was very informative, great subject matter experts, on these topics. So for anyone that joined the call late, we have recorded this webinar and we're going to be sending it out via email afterwards. So with that said, I just want to say thank you again for everyone joining today, and have a great day.
Yep. Thank you.
Thanks, everyone.
Bye, everyone.
Bye.
Right.